Okay, so after our last lesson, we're going to jump back now to modeling our plants again. Let's come to our image here, and we're going to start on our third plant. And by our third, I actually mean our second, this plant B here that we skipped earlier. So this spiny looking one that's on a stem is going to unfold, and then our spines here are going to unroll as this sort of unfolds itself. So far we've animated unrolling of our plants with kineffects and keyframes that we sort of did down here. We have used a bend deformer that we used on this one. And here we're going to use kineffects again, but I'm going to show you how we can modify the transform matrix on our joints to create a kind of cool unrolling effect. It's going to be a pretty fun setup now that we know a few of our matrix functions. So let's start with the stem, and let's put down a new geometry container here. Let's call this one plant B. Tap C just to color this again, and let's just dive inside. So we'll start here with a curve SOP. I come to our viewport. I'm just going to hold down our spacebar 4. You can just easily flick between your views by 1, 2, 3, 4. 4 is for the right. Let's just make sure we've got a handle selected by pressing enter if we haven't, and just zoom in here. I'm going to hold down X to enable snapping. I'm just going to turn on grid snapping for a moment just to snap to our origin. Let's hold down X again and just click it to turn off. So I'm going to put down these 3 more points here, just finishing sort of just after 1 unit. If I press enter, we can now just click on the individual points and just move them around if we need to. So next we'll put down a resample to smooth this out. Let's set our segment length to be half of this, so 0.05. Let's make this subdivision curves, and let's enable our curve view attribute, which we'll use later. Select our curve again, and we can just refine this a little bit more if we need to now that we've got it smoothed. Sort of something like this, with this nice S shape is what I'm going for here. Okay, so let's put down a sweep next. I'm going to jump back to perspective with spacebar 1, and let's put down our sweep SOP. We're going to connect this to our first input, and then just make our surface shape be round tube. I'm also going to tap Shift W just to enable wireframe. You could also do that up here, smooth and wire shaded. Okay, let's reduce the radius a bit. I think maybe about 0.02. I'm going to have more columns here because this is the stem. I'm just going to make it a bit more subdivided, so let's go for 16. I'm going to make the end caps to be grid, which will give us this nice rounded end. You can adjust this with the roundness and our scale here, but we'll just set it to 1 and 1. So we've got a nice round end cap. And I'm going to come down as well and just enable our apply scale along curve. Just going to expand this a bit. Let's bring down our start sort of somewhere around here. End can be somewhere around the same. Let's create one more curve in the middle, or curve point, sort of around here. I'm going to shift select all of these and just change them to be monotone cubic. Close that one up. Okay, so this is our basic stem here at the moment. So as I said, to animate this, we're going to use kineffects. And as before, I'm going to put down a skeleton SOP next. So let's go back to our resample here. Let's put down skeleton. View that and just stash our input. Press OK. So this is going to load our spline into sort of our skeleton SOP itself. And you can already see we've got our joints there set up. I think you need to have the handle enabled, so just make sure you've got that if you need it. So if we look at our attributes now on the skeleton, you can see kineffects has added a bunch of different attributes here. And one of these is local transform. And this is a 16 float or 4x4 matrix. And if we open this up in our spreadsheet here, you can see, in fact, that this is exactly what we have. Just 16 float points here for every, 16 float numbers here for every point. And so this is exactly the same pretty much as what we had before with our last transform matrix lesson. And all this really is it's going to give us, for each point, the position of the point relative to its parent. So the transform for this will give you the position based on this, and this one is the position based on this. So if we were to adjust this local transform matrix for all our points, we can get some pretty interesting animation that will just propagate down our chain. So I'm going to use our rotate function we learned in the last lesson to now adjust this and unroll our curve. I want to unroll this one down the z-axis here. So if we were to use our x-axis as our rotation axis, this will then spin around here and we can unroll down in this direction along our z. Okay, so let's just set that one up. I'm going to come just above our skeleton SOP. I'm going to put down a point wrangle. It's going to create a custom normal here. So let's just view that. I'm going to type v at n equals, it's going to do open curly brackets and put 1, 0, 0, just to set our normal to be on the x-axis. Already done something wrong here. It's not that bracket, it's curly brackets. So there we go. And if we enable our normals now, you can see we've just created normals that run straight down our x-axis, which is what we'll be rotating around. If we come to our skeleton, you can see we don't have this normal attribute, and that's because we need to just restash that. So it's going to reload our geometry into the skeleton SOP. So we now do have our normal here. Okay, so with that done, let's next put down a rig wrangle. So a rig attribute wrangle. This is kind of the same as a normal attribute wrangle, except it's sort of set up for kin effects. So we're going to leave this in point mode. And let's put down our rotate expression to start. I'm going to put it in comments just so we don't error out our wrangle while we're typing this in. So rotate M, we're going to need an angle and an axis. That was the function itself. Okay, so let's create first our angle. Float angle. It's going to be equal to, let's create channel float. Let's just call this our angle. And as before, we want this in radians, so let's just convert this to radians. Okay, so we will then put this into our expression, so rotate. Now, the matrix itself, we're going to use our local transform. We're not going to need an identity matrix here because this local transform is basically already set up with everything we need. We just want to rotate it. So if we type here at local transform. Now in terms of the type, again, if this was like a float attribute, you type F. If it was a vector, you type V. For a 4x4 matrix, you type 4. If it's a 3x3 matrix, you type 3, but we're going to use 4 for a 4x4 matrix, and it's called local transform. In brackets, we'll just put our angle, which is what we're going to rotate by, and for our axis, we're just going to use the normal, so attribute N. We'll close out that. Let's create this, and we can now rotate this. Let's just go to our angle. Let's just make this a bit more friendly. Let's go a range of -180 to 180. Accept that. So now we can now rotate around like this, which is pretty cool, but we're currently rotating everything by the same amount here. What I want to do is actually multiply our angle that we're rotating by our curve view of our spline here. So it's going to rotate points at the end more than it will at the start. We can do this pretty easily. We'll just type angle, we'll just do times equal to float attribute curve U. Okay, and so now as we move this, you can see we're getting this nice sort of spiraling, curving animation along our thing. So let's animate this next, and rather than actually animate the angle, what I'm going to do is animate a mask based on our curve U and multiply that against our rotation. It's slightly different, but it creates a slightly different sort of look to our animation, which I preferred. So this is what we're going to do here. It's going to set this back to, say, I don't know, let's go -90. So we've got a curve U on our points. Let's just jump back to this a second. I'm going to turn off our display of our vectors here. And just to demonstrate this a bit better, I'm going to right click and hold control and right click and just click on our curve U here. If we enable our visualizer, just make sure it's enabled. Sometimes you need to turn it on and off. I'm actually going to change this for now just to be, instead of color, I'm going to change it to be marker so it shows us the value. If we zoom in here, you can see we've got our curve U values going from 0 at one end to 1 at the other and everything else in between. So what I'm going to do is essentially offset this value. I'm going to clamp it and then we're going to send that to be a mask, and we can use that to offset our angle. So just to show this, if I put down a point wrangle, if I was to set float at curve U to be equal to, well, let's say plus equal, so we're going to add a value to this, and we're just going to call this slider called offset. This isn't actually the setup at the moment, but I'm just going to show this because it's a little bit easier to explain what I'm doing. So let's create that. I'm going to come up here, edit our parameter interface, and just set this to be -1 to 1. This is kind of like a controller here. So if I was to now move this, you can see we're just basically adding this value to our curve U attribute. So if we set it to 1, we're now going from 1 to 2. If we drag it down, we're slowly reducing that all the way to the other end where it's -1 and 0 now. So if we were to also clamp this, so float attribute curve U equals clamp, we're going to take our current curve U attribute, so attribute curve U, and we're going to clamp it between 0 and 1. We've now pretty much made a mask. So as we go up, we've got 1 now. As we bring it down, we're getting values in between, and then it clamps at 0. So we have this kind of 0 to 1 mask that runs through our spline. Okay, so instead of actually adjusting our curve U, I'm going to want to retain that. So we're actually going to create a mask, and I'm going to do the same thing on that mask attribute. So let's just jump back now to our rig attribute wrangle here. So let's start by creating a float mask. I'm just going to make it to be exactly the same as our curve U. Let's add in our offset, so mask plus equals channel float offset. We'll create that, and once again we will just edit our parameter interface, so this is -1 to 1, which is the sort of range we are looking for. Let's clamp this, so mask equals clamp mask 0 and 1, so we won't have any values less than 0 or greater than 1. And then let's now multiply our angle by the mask. And there we go. So now it's kind of doing this kind of more unrolling effect here. I'm going to turn off our visualizers for a second, turn off this as well, just so that we don't see this. So it's actually kind of looking like it's rolling down the spline now more than just one big unfurl. And I much prefer this, so I'm going to use this for now. So let's animate this. I'm going to go to frame 1. I'm going to set this to be 1. So I'm going to alt click on this, I want to come up to, I'm actually going to go to 125. I know I said I was going to unroll between sort of 3 to 4 seconds, but I think I'm going to make this a little bit longer just for the effect. So let's come to 125. Let's set this to be -1. I'm actually going to come here and I'm going to set this to be just linear keyframes for now. We're actually going to use a smooth function to essentially add some ease in or ease out to our unrolling here. So the smooth function is pretty cool. I'm going to put down mask equals smooth. And let's in fact just press F1 to look at this to explain it a bit better. So our smooth function basically computes an ease in or ease out, and it's going to compute a number between 0 and 1. So often you'd want to multiply this by a value, but we actually just want a value between 0 and 1 in this case, so we can use the value directly. So you put in 2 values and an amount. Now our mask is going to be amount. We're going to use a value between 0 and 1. And then based on this roll-off value, it's going to give you sort of like a fall-off curve for easing in or easing out. And just if we go down here, we can see that if the roll-off is greater than 1, the shift will be to the right. If the roll-off is less than 1, the shift will be to the left. So let's just set this up and try this out now. So let's just open this up again and check what we need. So float value 1, float value 2, float amount and roll-off. So we're going to go from 0, going to go to 1. Mask is our amount. And let's just make a channel float slider to call this roll off, just so we can adjust this a bit more interactively. Close that one out, create that parameter here. And let's just see if I've done anything wrong here. So currently the roll off set to 0, so it's not doing anything. Just to compare this, I'm going to copy this rig wrangle. And I'm going to remove this line here so we can have what we had before. I'm going to make this templated, so now we can view what this effect is doing based on what we had if we didn't have the smooth. So you can see at the moment we're kind of delaying our animation based on our original. If we bring our, make sure I'm actually clicking on the right one, so here we go. So if I bring our value down, you can see we're almost easing in more at the start, and then it catches up at the end. If I bring our value up, and in fact go above 1, let's say about 1.4, you can see that our value sort of moves out faster, and then it slows down to the end. So we're getting like an ease in or an ease out based on the value we're setting. So I'm going to go for a value of about 1.3 here. I think that worked quite nicely. And we just press play and we can see this is now our unroll here. Okay, so let's just delete that. We don't need this anymore. And we've crashed. And we're back. You can always guarantee there's going to be a crash sooner or later. It's always right at the end of a recording. Luckily, autosave worked and it saved it just before the scene crashed, which almost never happens. So we've recovered the scene here and I'm going to carry on now. Okay, so let's just quickly clean this up a little bit. I'm going to come back up to this point wrangle. I'm just going to call this set normal X. I am going to come down here. I'm going to delete this. We don't need this comment anymore. Okay, so we've got our angle we've set. We have created a mask based on curve U. We're going to leave curve U as it is, but we're going to set the mask to be that. We're going to then offset that mask by an animated amount. We're clamping that between 0 and 1. And then we're going to smooth that with a roll off just to give it a bit of ease out. And then we're multiplying our angle by that mask. So the end result is this. Let's come down to our sweep next. And you'll probably notice that it looks a little bit weird now. First of all, I'm going to give it some more subdivisions here because it's looking a little bit blocky. So let's put down a resample. I think maybe I'm going to do just a maximum segments of Let's try 50, something like that. And of course, make this subdivision curves again. So yeah, as you can see, while it's not bad, it looks a little bit skewed now. Specifically, these end caps are all gone a bit wonky. So the reason for this is kind of twofold. First of all, we've still got our normals coming through here, which we're set in our X direction. And while the sweep is pretty good, I think these normals are kind of throwing it off. We've also got a bunch of extra attributes put on by KineFX. I've got a feeling that things like the local transform of our joints, if you're using it for a curve afterwards, it can kind of mess things up a bit. So let's just clean off our geometry. It's a good idea anyway, just to have nice clean attributes as we move forward. So I'm just going to keep our curve view and our position, which we can't delete anyway, but I'm going to get rid of everything else. And we've also got a detail attribute there. We'll also clean that off. So let's just put down a attribute delete quickly. And I'm going to delete all, so put star for everything except our curve U. And we can't delete P, so that will stay there anyway. Going to delete all our detail attributes. Now we have nice, clean attributes going into our sweep. Okay, so if we click on this now, turn off those, you can see this looks much nicer. Everything is much better. And here is our animation now. So one last thing I want to do is I think I'm just going to counter rotate this. So as it rolls out, I'm going to have it rotate around from the other way. And I think it's going to make a nice little sort of thing to our actual scene here. So let's put down a transform, SOP. I'm going to come back to, well, let's just rotate it first. So let's rotate this back. Let's go 180 degrees. I'm going to make a keyframe at frame 1. I'm going to come to about maybe 105 or something like that, and I'm going to set this back to 0, the default. Keyframe that one. Let's just see now. So we get this kind of nice sort of whoop. I'm going to shift click on this just to open up our curves in a new window. Press H, and I'm just going to adjust these keyframes handles a little bit, maybe just bring this back a little bit more so it moves into that end position earlier. Nice. Okay, so I think that will do for now, and then we're going to move on and set up our spines next.